and not only in India but even in entire world. And you might be surprised that these plants, Nalgonda technique-based plants, are still operational in some of the countries in Africa. And we have come long way since we developed this Nalgonda technique. And then we have many such technologies. And as I told you, that almost 15 CSR institutes have developed these technologies. I would like to say share the compendium which was released last year. And if we go through this compendium, we have like 66 technologies developed by 33 CSR 13, sorry, 13 CSR institutes. And I'll share this if it can be opened by me. It seems difficult for me to open, but anyway, I'll share those who want this water technology manual from us. This is uploaded even on CSR website. It gives details of these technologies and where actually these technologies have been developed, who's the contact person, who can share details of this technology and how this technology can be even transferred to any interested industry. Coming back to today's theme, we'll be having a first session in which my colleagues from CSR will be presenting on different water treatment or wastewater treatment technologies we have developed. After that, two of our colleagues from industry will share their experience, how they have taken the license of the technologies and taken these technologies to the field. How is their experience? And we have then a light panel of engineer-in-chief from Public Health Engineering Department of Madhya Pradesh. He'll be joining us in panel discussion. He'll be sharing his experience about, say, sustainability of these technologies. And we will be having a panelist like Dr. Shahi, who will also be sharing his experience of membrane-based technologies. In addition, we have many technology partners, in addition to scientist Dr. Rao from ICT and our former director of CLRI, Dr. Mandal, who will also be sharing their experience. So we have like it's a great agenda ahead. And with these few words, I look forward to your contribution to this particular paper. We particularly want some inputs from our industry partners that how should we evolve further. How is their experience about taking these technology to the field? How can we better handhold them? What sort of inputs they need from CSR so that the technology transfer becomes slightly easier? So with these few words, I hand it over to my colleague, Dr. Sridhar from ICT, and he'll be making presentation on his work on membrane technology. In addition, he will also be talking about technology which have been developed in other labs. So over to Dr. Sridhar. Thanks a lot.
Thank you very much, Dr. Pawan. I hope my screen is visible and I am audible. And
yes.
And really very happy to be on iConnect and also to present our experiences as far as water treatment is concerned, especially membrane-based water treatment. And as Dr. Pawan has introduced, this is mostly for purification of contaminated drinking water resources as well as generation of potable water using atmospheric water generator and also treatment of saline water. So mostly CSR's approach to membrane-based water treatment has been like it is based on the TDS as far as drinking water is concerned. It is based on the total dissolved solids, and several labs led by CSMCRA Bhavnagar with their indigenous RO system have been treating groundwater, brackish water and seawater with like desalination, seawater RO membranes, brackish water RO membranes, and also we also have at a high pressure, and we also have now nanofiltration technology coming up quite well with IACT contributing for moderate TDS groundwater, because we need a TDS below 500 and it is not necessary to go for RO for all the different types of water resources that are available. So moderate TDS groundwater and to some extent surface water with little lesser rejection, low rejection nanofiltration membrane, we can go for we can treat both moderate TDS groundwater and surface water. And as far as flood water and of course the usual water that we find in rivers, lakes and ponds, we have treated with ultrafiltration. And apart from CSM, CRA, ISCT, Niri Nagpur is quite involved in these activities. And then CSR, CGCRI is also there. NCL Pune has been in the forefront, and CMERA Durgapur is also there. So these all labs have been working on this. And ISCT's application has it's been an application-oriented selection of water treatment processes. So as we can see here, the seawater, brackish water, RO has been as at the forefront for high TDS groundwater and sea and brackish water, whereas for moderate TDS groundwater we have preferred nanofiltration over RO. And then for flood water, especially during the floods in Kerala, and then of course in Maharashtra in Sangli, and then Gokak, etc. in Karnataka, and also several states, Bihar, Assam, also we have covered Orissa and West Bengal. We have covered West Bengal, like nearly 10 plants in for both Yas and Amphan cyclones, using hand pump operated ultrafiltration systems, which can be later converted to power driven ultrafiltration once the normal power supply is restored after the floods. And at some points we have tried nanofiltration also for pond water. In water scarce regions, we are looking at atmospheric water generator. I'll show a brief video on that. And then as far as industrial effluents and domestic wastewater is concerned, apart from the pressure driven processes, we have also tried electrodialysis. Is like even CSMCR is working on unsupported membranes, which are working very well for electrodialysis. They are polystyrene based. And we have also been using electrodialysis for desalination, deacidification of effluents. And then we also have membrane bioreactor technology across CSAR and microbial fuel cell. And packaged drinking water, this has been one area where ISCT has taken up. And we also have ISI mark, that is BIS certification, as well as FSI, and that is RO with remineralization for groundwater or nanofiltration with like more minerals. So it's called as Reminero brand. And then water for therapeutic applications, medical grade water. This is also patented technology where we have double pass RO followed by resin and UV. And this water has been used for more than 1 lakh patients for dialysis in Nephroplus and other hospitals. Then recently alkaline water up to 8.5 pH it is preferred, so that we are within the BAS limits, but at the same time it can prevent hyperacidity and joint pains. So I will not go too much into the detail of what exactly membrane processes, as most of you will be aware of that, but just for the sake of the audience, membrane will be a thin barrier that separates the components of a liquid or gaseous mixture based on not only molecular size, but sometimes you can have affinity based separation as well. So size based exclusion at times, and depending on porous membranes, and when you have non-porous membranes, you have got affinity based separation. And this is a video on the hollow fiber membranes that are being developed at IICT. You have a polymer tank here, and then you can see the hollow fiber membrane, which has a bore that is generated by using a bore fluid. Polymer fluid flows on the outer concentric opening, and from the inner opening you have a bore fluid coming out, that is mostly water, and you have a polymer solution that is dipped in that is mixed in a solvent, and you have a homogeneous honey-like solution of viscosity about 5000 centipoise, and then you can draw fibers at the rate of 30 meter per minute, and with 1 kg batch you can draw about 5 to 6 kilometer of fiber and make several modules among that. So high surface area per unit volume, ladies and gentlemen. And then we have flat sheet membranes also, and this particular machine gives the flat sheet of 14-inch width, and then it is trimmed down to 12-inch width, and modules are made. And here larger machines are available with CSMCRI Bhavnagar as well, who make the bigger modules, that is 8-inch modules as well. And these systems are now, for example, now you see the phase inversion technique for flat sheet. Here, unlike the hollow fiber, it is not a self-supporting structure, but you have got a porous substrate that is there to give mechanical support to the membrane. And after phase inversion, Now, for example, we have got now this polysulfone in dimethyl formamide solvent, and you are getting the membrane coming out here, and that is how it finally looks like. And this is the shiny side of the membrane. This is an ultrafiltration membrane, and this is coated with another layer by interfacial polymerization to get. So several membranes are can be made for different applications, and the focus of this theme has been mostly on the thin film composites for RO nanofiltration, where we use piperazine as the aqueous reagent. So we come down to the next application, treatment of surface and flood water by ultrafiltration, and we also have nanofiltration. So this has been CSR IICT's response to floods through water purification. During the 12th 5-year plan, with CSM CRA as the nodal as well as NERI as one of the partners, we developed jointly this technology, and this is based mostly based on molecular sieving to remove the turbidity and the microbial content, including bacteria and virus. And we have a smart chlorine cartridge to, now you can see the hand operated scheme here, and you have got, instead of now the chlorine tank, you have got a smart chlorine cartridge here. As you can see here, you can see the difference in the water, and these are some of the submerged where you are using suction pressure to draw the water from the modules. Here there is positive pressure, and this was implemented in Wayanad at Trivandrum, Kuttanad, and Kottayam. 8 plants were installed, and you can see the water being drawn by a hand pump. Later it can be replaced once the power is restored. We can replace it with the electric pump, and now the hand pump pushes the water through the pre-filtration micron filter cartridge to remove most of the turbidity, and then the membrane takes care of the bulk of the microbes and the colloidal impurities, and you can see crystal clear water coming out. A smart chlorine cartridge is provided to take care of any secondary contamination here, and here you can see 700 liters per hour is the capacity, and you can see the clarity of the water. And during floods, it is very important to prevent the diseases, waterborne diseases like jaundice, typhoid, cholera, gastroenteritis, etc. And one very important, now this was response to Assam floods, Chirang, Barpeta, along with, this is in Karnataka and Maharashtra. One important factor you can see in the analysis, bacteria content is 0, and you can see that the TDS is always within range, so it doesn't really filter out any TDS, but it removes the turbidity and the microbial content. So this is in Amphan cyclone, and this was little challenging because of the COVID situation, and we had to really struggle a little bit to reach the remote areas of South and North Parganas, 24 Parganas district here, and we were able to supply water to quite a few thousands of people, and some installations in schools as well. Now nanofiltration, we can see that most of the hardness is removed, only part of it is allowed, and most of the monovalent ions are allowed. So this can be used for, like surface water, pond water here now. You can see at Mogalu village in West Godavari district, and feed TDS was around 324, and the permeate TDS was around 57, and by sand bath heating you get it to be around 80 to 90 TDS, that is the ppm. And earlier they were consuming water directly from the pond, and that was very hazardous. And we came up with this vertical modular plant, and you can see the ozonator here. You also have a small UV here, and this is about 1000 liter per hour plant, and the plant is running very successfully since the past 4 years or so. And this is one in Gandhi Hospital in Hyderabad, which was commissioned in 2019 January. And this is for Gandhi Hospital, and not only for the patients and the staff and the doctors, but also for the attendants. And reuse of reject is very important, and especially the reject is much smaller volume in ultrafiltration, less than 5%, whereas in nanofiltration we can reduce it to less than 20% and reuse it for washing and other applications. So here in IICT itself, we have a model plant which is being used in the last 9 years for cooking, and the entire beverages and food is made from that, and the reject water is used for washing the vessels, etc. And this is in Vendra district, where we have IIT Kharagpur as the nodal, and we have this plant installed there, 300 liter per hour plant for the school children. Again, moderate TDS groundwater, 700 to around, it brings it to around 300, so that is fine. Then drinking water camps based on nanofiltration at Hyderabad exhibitions, and also in school exhibitions where we have trained school children as well. And this is a free water drinking camp, free drinking water camp on the airport road, and it is has been quite active until COVID period, and we are now going to revive this. And you can see that all the urban, this is for basically urban development, and all the pedestrians, the commuters, and the bus drivers coming up, and it's almost become like a virtual bus stand. And then we have water scarcity. So when there is no water, what do we do? There is no water to treat by membrane process. So there we use the atmospheric water generator, and this has been developed in collaboration with Maitri Aquatech, and it is based on the inverse Carnot cycle. You have two fans, one to draw the moist air inside. So relative humidity is the key, and about 25% it will work very well. And in coastal areas and hilly areas, like for example in Shimla, schools were shut down for some time due to excess tourist load and lack of water there. So groundwater is very scarce there, but there is plenty of moisture in the atmosphere. Relative humidity is more than 90%. So here it works very well. So for certain areas like border areas and Coast Guard and Border Security Force, coastal areas, this is very useful. And in Hyderabad, there is a company now which is also making the water, bottled water from this water drawn from air. He has a 5,000 liter per day system, and the air goes through the pre-filter, that is polypropylene cloth, 5 micron pore size, and hits the evaporator, just like in AC or refrigeration, where the compressed HFC gas evaporates and brings about cooling, and then the water gets collected here and it remineralized with rock salt and other mixtures, so proprietary salt mixture, and the exhaust air is also removed immediately. So the compression and the evaporation cycle goes on as far as the refrigerant is concerned, and around 55 degrees is the compression temperature, and the 4 degrees is reached at the evaporator for dew point of water. So this is the cycle that you can see, and Dr. Mashelkar.
Either if you can kindly conclude in next couple of minutes, please.
Yes. So we have this now, the Meghdut going on here, and you can see the water coming. So here you can see the water drawn from the atmosphere. So it has been installed in several places, including Kerala flood relief, and these are recent installations in Uttarakhand. And this is defluoridation of groundwater. We are quite familiar with this, and reject has to be disposed carefully. So industrial wastewater treatment. So pharmaceutical effluent, I'll just give an example of DMSO, sodium azide separation from DMSO. So sodium azide is separated by electrodialysis so that the liquor of DMSO and water doesn't explode. And then we go for distillation, first stage and second stage, after removing the explosive sodium azide, and plenty of DMSO has been recovered and reused for making the antiretroviral drug risidovudine. This is for pharmaceutical effluent. So block diagram of nanofiltration plant, we have two pumps running in tandem. The thiocyanate that is used as a solvent, and this solvent is purified by nanofiltration, which allows the monovalent thiocyanate to pass through and the bivalent ions are rejected. Similarly, Tata Steel, where we have a high recovery plant, 80%, with high water recovery, 85% water recovery. Only chloride is brought down here to less than 500 ppm. And this is a recent one, high pressure RO using a thicker RO membrane, and it has been working very well at Boisar in Maharashtra for treating aroma containing effluent. And I'll just show a brief video and try to conclude here. So this is the pre-filtration section. These are the membranes, and you can see the conductivity values. So high COD rejection, more than 70% COD rejection in the water. And then ultra pure medical grade water, I think we already discussed this, and I would just like to show these two systems. One is in plastic body. This is an import substitute for Milliq and Sartorius. This is metallic body, and this is the polymeric body, and it has been very widely used for dialysis and also for lab grade water. And this is a video of this system that shows, you can see the flow rate now, and a resin double stage RO with resin hydrophilized polyamide. So we don't have to intervene with any chemical washing. And now we can see that it has gone into the resistivity level. So it shows nil TDS, but actually it is in resistivity level. So as you know, ladies and gentlemen, these are some of the challenges which we will discuss during the panel discussion, and future prospects involve UF aided moving bed bioreactor for STP, and solar powered RO as well as atmospheric water generator for coastal area, and for atmospheric water generator for the arid zones including Latur. We are targeting Latur. So thank you very much for your kind attention, and I will answer your queries in the chat box.
Yeah, thanks, Dr. Sridhar. It was very comprehensive presentation. You talked about various membrane-based technologies we have developed, not only in IICT, but in other laboratories. So Dr. Shahi will also be there speaking about membrane-based technologies, which his team has developed in CSMCRA. Thanks a lot, and it is really very good presentation. Now we'll switch over to the next presentation by my colleague, Dr. Priyabrata Banerjee. He's principal scientist with CSR Semeri, and he'll be talking about wastewater and fecal sludge treatment technologies. Over to you, Dr. Banerjee.
Yeah.
I request if you can conclude your presentation in 12 minutes.
Okay, sir. Sure.
Thanks.
Am I audible, sir?
Yeah.
Screen is visible, right?
Yes.
Okay. A very good morning. My sincere thanks to Dr. Pabul Lepshitar for nice introduction and for the deepest concern regarding the waste water management related issues. And truly, I think that in today's scenario, the technologies for treatment for contamination, that is the contaminated wastewater, rewater with sludge management, is of today's concern. And you know that is today several CSL are working in this area. So I will showcase a few of those technologies which are really very challenging and who are doing tirelessly, but the main concern is coming from the wastewater related issues. Now you know that is in Indian perspective, up to 2025 there will be 843 billion cubic meter of the water demand, and which will be raised up to 1180 billion cubic meter. Now concerning 54% of Indian nowadays faces the high to extremely high water stresses. Now it can be solved if we consider the effluent waters. Now 1,754 million liter per day. You know that is, hello, someone, yeah, of which the 22,963 million liter per day of water, it is only taken care. So the rest amount of the water which is left untreated, if we can consider that to treat it with our existing technologies, the CSR technologies, I think it will be the viable solution. And I know that today there are so many eminent panelists and also eminent speakers are there. So I think, and there are also several industrial partners. So if we all jointly hand together, then perhaps from the CSR portfolio, we can give the proper ultimate solution to our community, and then it will be the best solution in the auspicious event and in the context of 75 years Azadi Ka Mahotsav. And you know that will be the best tribute to our Mother India. So now there are several CSR product, several categories. I am not going in detail. There are CACO-based treatment plant and also the hydroid wastewater treatment technology. Now the CACO-based treatment plant, you can see from here that it is already well tested. It can produce from 50 meter cube per day to 120 meter cube per day to 750 meter cube per day, and up to even 2000 meter cube per day. So why not? We can spread it in several places. And similarly, the hydroid wastewater treatment technology, also another one. Now, if we consider the this activated carbon oxidative technology, chemoautotrophic activated carbon oxidative technology, this is the most primitive one. And there are also others like FACO technology and FICO technology. Now, FICO is the Excel grade, that is, you know, that is performance up to the imported technologies. So if we can consider those technologies, if we see their, you know, that specifications, that is that they are less water emission, their electrical energy consumption, their operational cost, then we can understand that all these technologies can be taken care in coming days, and wherein these products are already in high TRL level and they are already IPR protected. Now regarding the wastewater management, we can tell that CS and NIDI, they are doing really a noteworthy job. You know, whenever actually Dr. Sridhar is also telling about the membrane-based technology and their beautifulness. And in the other hand, if we think about the adsorbent-based technology, it is also another way out. So herein, in the flooded area, when sometimes it is not possible to give all the solutions at a time, then the most primitive, that is, and most straightforward technology will be this one, where the adsorbent can be taken care. And it also bagged the Nina Excellence Award, and it is easy to operate, typical capacity of 20 liter per hour, no power requirement, and these are also IPR protected. Similarly, there is also another technology, the phytorite plant-based technology, which is already well acclaimed, and that it is already advertised throughout the CSR and other places also. High TRL, no foul odor, no mosquito nuisance, small footprint, minimum electricity requirement. So these are the unique features, and it is the immobilized microbes for treatment of municipal wastewater in more efficient manner. Now, in between, when we are talking about these pilot-based technologies, then in between there are also several technologies which are also developed by CSR, CMERA, and CSR NIST. If you think about the number 1, number 3, and number 5, and also number 6, these are from the CSR, CMERA, which are already developed, and these are the wastewater treatment technology. I'm not going in detail because time is very short. If you are interested, we can think about it, talk about it with our business development group. But I can only tell you that these are the very straightforward, and compartmental wise, you can purify the systems. And one of the best is the vehicle mounted mechanized drain cleaning system. This is one of the new feathers added in CSS CMR arena. And regarding the aqua high anaerobic reactor for complex wastewater treatment behavior, and also the NOAA technology, you can see these are also well documented. It can handle COD 500 to 4,000 milligram per liter. It is economical, IPR protected, and these can be utilized for the treatment of the organic rich wastewater from small establishment like canteen, restaurant, etc. And similarly, for the buoyancy-based anaerobic reactor for complex water treatment, the PFBR, you can see it can also taken care for the complex wastewater containing high COD, oil, fat, and also anaerobic wastewater treatment. So this type of technology, if we can advertise those technologies in a bigger manner, then perhaps the wastewater to potable water formation, whichever the problems are coming in coming days, we can take these, we can solve those issues. Now, regarding the CSI CMERI vehicle mounted mechanized drain cleaning system, is that this technology is wonderful because in terms of the cost effectiveness, the existing technology whichever is now in the market, these are improved, but herein it is really in a very minimal cost. And if you see the specifications, that is its jetting pump 35 horsepower, suction pump of 5 horsepower, mechanical filter water will be used for the jetting system, so no extra water is needed from the outside. In the other technologies, whichever is there in the market, the point is that they have to take the bucket water from the outside. But herein, the in situ water will be purified and it can be taken care. It is a 4-stage eco-friendly purification system with a proper suction pump, and this drainage water will be reusable in the agriculture purpose, and for it is quite reasonable. So for the vehicle mounted, that is, it is a movable technology. So whenever there is a flooded system during the flood and other time, you can think about whether there is any choking, then immediately that can go and can solve the issues very easily. I think today there is also Dr. Maniar and Mr. Makiraju. They are the industry partner taker, so they will tell about this briefly maybe. Now, whenever we are already, Dr. Sridhar also tell many things, and also Dr. Pavan Lepshetar also tell about the Nalgongla technique. So I am not going in detail on that part. My point is that whenever fluoride, iron, arsenic like contaminations are there, so we have to think about what is the requirement. The requirement sometimes in the domestic level, sometimes in the medium level, sometimes in the bigger level. So based on this criteria requirement, we have developed, designed several water treatment plant. And this is the beauty of the CSS CMRA also, because it is a mechanical engineering lab. So we have drawing design aspect in such a manner that you can take care of this part in a very efficient manner to control the flow rate, but you are getting the you are not compromising with the water quality. So that's why from 1 to 6 all are different, this type of fluoride, iron, arsenic removal technology, and from a few liter per hour, that is domestic, up to 10,000 liter per hour. Now, of this defluidation, dearenation, and dearsenification unit, the dearsenification unit, it is already, that is, it is awarded winner of CSR Technology Award 2017, and good TRL level, already gravitational based filter. Similarly, for the defluidation and dearsenification, these are also, you can see all is depicted here, the raw material cost, equipment cost, everything we have pointed out, and all these three technologies, they are IPR protected, and so and they are also well implemented, and technology are transferred in several places. Now, when the requirement is in a more bigger way, that is from the 5,000 liter to 10,000 liter, that part also taken care of from the CSI CMRI scientists and also from the technicians and the, who are designing part. The designing part are taken in such a manner that the flow rate will be controlled in that particular issue. And the adsorbent lifetimes are quite reasonable. Simple backwash technique for adsorbent reuse and adsorbents taken care for the sludge management system. Now, there is another technology that is a numphere, and with this name, you can see fluoride, iron, and arsenic removal technology, wherein 3 problems are taken care with one solution. You can see the technical specifications and everything. Purification is 2-stage and very nominal charge of the waters. And these are 2 things. That is, one is the domestic level, one is in a pilot level. So now this is the best technology I think the CS and TD have developed, that is the electrolytic defluoridation technique. This is one of the best in its category when the electricity requirement is there with the DC power suitable to fabricate, and the produces the potable water with a palatable taste as against the other treatment methods. And I think cost is very reasonable, only rupees 25 to 30 per 1,000 liter, capacity wise 2,000 liter per batch in 3 to 3.5 hours. And this is the really good technology, great technology, because it has already several accolades in its favor, recognition from national as well as from the international places, PIA award, IWA award, DST Lockheed award, everything backed by this technology. And it is also well implemented in several districts in Madhya Pradesh, and not only in Madhya Pradesh and other sites also. So I think this type of technologies, if you industrialists, you can implement it with time, then it will be perhaps the best solution in the context of India wastewater management. Now, I am not going in detail because there are also several other technologies from CSS CMRI, like drinking water resources, when we can harvest of the rainwater. What Dr. Sridhar also told in his slides, that is, there are several technologies in harvested rainwater system. Herein the beauty is that we have implemented here the adsorbents which are readily available in the local areas. So that porous substances, we did the post-synthetic modification with a flow rate of 2,000 liter. It is very reasonable. Cost of the treated water very less, easy backwashing technique. Similarly, also for the aqua rejuvenation plant, which is also that is highlighted for the irrigation purpose with a 15 to 20 KLD, main emphasis on the adsorbent-based technology, and the adsorbents are all patent protected. These adsorbents have the high surface area, which actually helps them to remove the the waste in a proper manner, and use of local resources along with the R&D modified multifunction adsorbent material are taken care. Now, this is another technology. Yes, sir.
You can conclude in next couple of minutes.
Yes, sir. Yes, sir. Only a few slides. So with the CSR IICT, they are also produced several biosolic process for the industrial wastewater treatment process. This is a beautiful technique wherein simultaneous removal of CO2 and ammoniac and nitrogens are taken care. And this is also very good technology, low carbon footprint. And similarly for the compact chemical precipitation integrated advanced oxidation technique. And it is why it is beautiful, because it is a CO2 and the removal of ammoniac and nitrogen is taken care. So you can see that the technologies are specified in such a manner they can be efficient in specific areas also. So if we can combine all those areas, all those specifications, we can perhaps give a wonderful solution. So there is another AAC. This is the third last slide from in my presentation. This is the AAC in CSR IICT. It is a wonderful technology, keeping in mind that it is the taking care of the biological decomposition product controlled conditions. It is feasible at ambient temperature, low cost, and minimization of the loss of the carbon and nitrogen. And it is already well documented, and revenue generation is already well implemented, tested, and whoever the youths who are unemployed, they can produce the self-help group and become the entrepreneur with this AAC technology. Now, the main concern about the gravitational based technology is that sometimes the sludge management. So whatever sludge are developed from the fluoride contaminated areas or the arsenic contaminated area, that part also taken care. And herein, by a proper combination R&D development, we have developed several bricks. And that bricks, after a repeated testing, it was found that, I am not going in detail, ACSB4 is the best in its brick quality, and it's that is the comprehensive strength is 15.97 megapascal, and we did all the studies like WLT, TCLP, AFET, and through which it is proved that okay, these bricks are really that is eligible for building purposes. Similar is also true for arsenic iron contaminated water treatment plant through microwave treatment, not going in detail. This technology is also well implemented and well tested and well characterized, all the things. So now the chemical sludge management, this is the last slide from my side. CSR, CLRI, they are producing the sequential toxic anoxic bioreactor SOABR and co-digestion of ternary solid waste. You know that is CLRI, they are also doing in a very fantastic manner. The oxic anoxic zones they have taken care, and the suspended particles, the oxygen removes the suspended particle by interception method, and anoxic zone digests the solids scavenged by the oxygens. So regarding the co-digestion of the ternary solids waste for the biogas generation, it is also another one wherein disposal problem of fleshing and WS in ternary sector can be minimized. You have no additional treatment cost due to using of the produced energy, and improves the aesthetic value and around the leather complexes. And this is already well implemented in the Calcutta Leather Complex, CLC Kolkata. So with all this, thank you very much. My sincere thanks to everybody for listening me, and my sincere request will be to all of you, all the industrialists and panelists, that if you can join hand by hand, then we can perhaps give our community a bigger solution for waste management, wastewater related issues. Thank you very much. Thank you, sir.
Yeah, thanks a lot, Priyabrata. It was very, very good presentation, and you have complemented to what Sridhar has already spoken about. And it really gives feeling of CSR, team CSAR, because we are presenting these treatment technologies developed by many institutes of CSAR. So if Dr. Sridhar is around, I have a question for him, because we'll break this monotonous routine of presentation, and there's a question from audience, Sridhar, for you.
Yes, sir.
And the question is, what is the cost per liter of atmospheric water? So can you please elaborate on it?
Yes, sir.
You mentioned, of course, but it will really
we-
benefit the audience also about it.
Yeah. If we go for the 1,000 liter per day plant, it comes around rupees 2 per liter, sir. And if we around rupees 1.5 per liter, 1.5 rupees per liter. And if we go for a slightly smaller capacity, say around 250 liter, 150 to 250 liter per day, then it goes to around 2 rupees per liter. So 1.5 to 2 rupees per liter is the cost of the atmospheric water. It is still a bit capital intensive, so I would suggest that it is installed where there is no water available for treating.
So thanks a lot, thanks a lot. And I request audience to kindly put their question on chat box, and we'll take this question at the end of the session. If these questions are prompted on chat box, we may ask these questions immediately after the completion of the presentation. So yeah, that's great. And then with this, we'll now move to the third presentation by team CSAR, and it will be presented by Dr. Ganesh who of CGCRI Kolkata. So he'll be talking about membrane coating, water purification. As you are aware, the CGCRI works a lot on ceramic membrane, and they also have experience of implementing the ceramic membrane-based water and wastewater treatment technologies in the field. So he'll be covering those details in his presentation. So over to you, Dr. Sahu. And I also request you to kindly conclude your presentation in the next 10 to 12 minutes, please. Dr. Sahu, your slides are visible. Please go ahead. But you are not audible.
Am I audible?
Yes, you are audible. Please go ahead.
Okay.
Please
I will be
slightly
presenting
loud.
ceramic membrane-based technology for drinking water and the facility established for the ceramic membrane preparation and the ceramic membrane coating developed for finer applications. Sorry. How to get the next slide? sorry. Ceramic membrane tubular configuration, it works in the cross-flow membrane filtration mode as it is shown here. The contaminated water is passing through the channel, and due to transmembrane pressure generated, the suspended particle is retained by the membrane, and the permeate is coming out the clear water. This membrane is housed in a membrane module, and membrane having the macroporous support over it, the mesoporous and microporous coating layers as per application. Since this is the cross-flow membrane filtration, the membrane fouling is minimum, and it is the foul layer is taken by the incoming flow of the feed. Now, the ceramic membrane-based water technology developed at CSIR CGCRI, it produce drinking water having arsenic level less than 10 ppb and iron less than 0.3 ppm from contaminated groundwater having up to 1.5 ppm of arsenic and iron up to 50 ppm. It is environment benign because the ceramic membrane is not hazardous, and it is having long operational life, and suspended particle is retained by the membrane, and clear water down to 1 NTU turbidity free water is obtained. The sludge is encapsulated in the system and taken for immobilization in the form of bricks and glasses. Also, it is having the back washing system so that membrane flux is regenerated in situ, and it is the IP protected. We have developed up to 10 meter cube per hour capacity plant, and it produces less than 10 paise per liter of drinking water, and the technology has been transferred to around 5 licenses, and there are more than 250 such installation at different northeastern states, border security forces, and border in Indo-Bangladesh border region. And this is high capacity module basically for the pre-treatment of river brackish water for feed of reverse osmosis system, and it is having the almost similar properties, and it is up to 2,240 liters per day output capacity. And the technology has been transferred to of our licenses, Messrs. Porel Das Water and Effluent Control Private Limited and Servo Technology from Faridabad. How the iron and arsenic is removed by the porous ceramic membranes, although it is having the pore size in the range of 0.2 to 1 micron pore size, because iron is groundwater in the form of iron 2, which is soluble, and in air oxidation it is converted to iron 3 hydroxide particulates, and it is retained by the membrane. In case of arsenic, it is in water in the form of arsenic 5 and arsenic 3. Arsenic 3 is not easily adsorbable, so it is oxidized by in air, or a oxidative coating is given inside the ceramic membrane so that it is oxidized almost 100% and retained by an adsorbent added in situ. So this is the way how arsenic and iron is removed by the ceramic membrane. And this is a schematic of the diagram. This is feed tank with a arsenic contaminated water, and the adsorbent media is added, and it is recirculated for half an hour for oxidation of arsenic and iron. Then it is membrane filtered to get clear drinking water. These are the few installation. This is installed in 2003 in the field condition till it is running without replacement of the membranes. So membranes having very long life. It is having no leaching effect and produce clear water which is having less than 1 NTU turbidity. There are many installation in northeastern states. There are around 29 plants installed at 8 northeastern states, and also there are 5 entrepreneurships. They are doing the water business there, and there are many installation for river water purification and as pre-treatment for RO, and this is a system installed at Ramchandrapur village, which is around 40 kilometers away from the Malda town on West Bengal. This is installed in Bihar 2018, and these are the some data obtained. You see, arsenic is much below the WHO limit of 10 ppb, more than 70 days of operation, and iron is much below the 0.3 ppm, more than 70 days of operation. And these are the ceramic membranes developed at CGCRI, hollow fiber, capillary, and single channel and multi-channel configuration. Also the surface modification, it is the hydrophobic membrane, zeolite membrane, palladium coated membrane for various applications. This is the extrusion die, which is the heart of the extrusion system, and this is also designed and developed, and we could develop, we could fabricate of 1939 channel ceramic membranes and various configuration by changing the membrane head. This is the process how monolithic ceramic support tube is prepared. That is the mixture of clay and alumina added, the binder, lubricant, plasticizers, admixing is done, adding the water, extrudable paste is made, and it is extruded, green tube is obtained, then humid drying, loading to the kiln and firing to get the firing at around 1550 degrees centigrade to evaporate out all the organics, leaving the pores. This is the 80-ton extruder at CGCRI. Now it is transported to Messrs. Prism Johnson Limited, Pay in Mumbai, for high-scale production of the membranes under a DST sponsored project. This is the how the ceramic membranes are extruded at industry premises, and this is a gas fire furnace established under the project. It is having more than 200 of membranes at a time in the 5 days of cycle is fired, and it is having around more than 10,000 such membrane can be produced in a year. This is laboratory single channel extruder to fabricate single channel membrane higher at 1550 degrees centigrade, and it is having high flux of 1200 liter per meter square per hour, which is international competitive membranes. Now this is the membrane housing. This is 7-element membrane. It is housed in the food grade SS module, and in the system it is installed. So it is having long operational life. Since now this is how the membrane coating is developed. This is the slurry is made from nano powders or from salts, and it is pushed into the channel by reverse siphon technique for a certain coating time. Then it is environment dried and fired at 600 to 1000 degrees centigrade to get various type of ultrafiltration membranes with MnO2 coating, zirconia, titania, and synthesized hydroxyapatite membranes. Also, we have automated coating machine. 10 numbers of up to 1 meter long tube can be coated at a time. Some characterization of these UF membranes, like zirconia membranes, it is upper, it is showing the water flux, clean water flux of the support membrane, and below it is the UF coated membrane flux of around 150 liter per meter square per hour at 1 bar, indicates that UF membrane is stable. Also, the separation study is done with contaminated water having more than 45 NTU, and the filter water is having less than 0.2 NTU water, and clear water is obtained.
So, if you can kindly conclude in next 2-3 minutes, please. And
it shows that pathogen contamination is not detected, DOD is also eliminated, and it is having the molecular weight cutoff near to 20 kilodalton using the PEG polymer. Similarly, titania coated membranes also have been developed, and it is having the molecular weight cutoff of in the range of 10 kilodalton. Also, some membrane surface modification using polymeric coating like fluorosilica coated membrane to obtain hydrophobic, super hydrophobic membrane to retain the water and allow the other desired product to pass through it. And also there are PDMS coating, polyether imine coating to modify the surface, and development is going on for various applications. Thank you for your kind attention.
Thanks, Dr. Sahu, for this presentation. And one more thing which you highlighted that, okay, these laboratories like CGSRI is based in Kolkata. And then these laboratories also try to cover geographical locations. So you've seen that most of their interventions are in eastern part of India and northeastern part of India. And then he has also talked about how the ceramic membranes are prepared and how effective these membranes are to remove geogenic contaminants. So thanks, Dr. Sahu. We'll pick up few questions once we get questions from audience and our chat box. But before we request our industry partners, I also talked in the beginning, we develop these technologies in the lab, we do all the R&D, but going to the field, we require assistance from our industrial partners. And they're very, very important, say, part of entire technology propagation. And we have like two colleagues. One presentation will be made by Mr. Iqbal Maniyar and Mr. Satish Machiraju, and they'll be talking about replication of CSR developed wastewater treatment technologies in the field. And there'll be next presentation by Dr. Shri D.N. Banerjee. But before we request them, I have a question from Rohini Deshpande Avle. From Nagpur to two colleagues from CSIR that you might be aware that we have a thermal power plant, and ash pond is an integral part of any thermal power plant. And we have two major power plants close to Nagpur, and then ash is disposed of in this ash pond. And unfortunately, there was an incidence of breach or overflow from this ash pond. And this fly ash slurry has merged with the Kanhan River. So there's a question that how can we treat this fly ash slurry from this ash pond, which we normally use for recycling? So this is the question from Ms. Deshpande. And before I request Dr. Sridhar, Priyabrata, and Dr. Sahu to talk about it, I have like some understanding about it. See what happens, we have like two contaminants. One is in dissolved form, and when we analyze ash, supernatant or slurry, we find that these metals are in dissolved form, whereas other contaminants are in say suspended form. So we can adopt two say pronged system. First, we can remove this suspended particle by any physical means like filtration or even sedimentation also. But when it comes to remove these metals, we can of course go for adsorption or even membrane-based technology. But cost will be an issue because we generate say a lot of ash pond water, and to treat that much volume of water will really be cost intensive. So we need to really work out optimum solution. And we can help definitely this thermal power plant to tackle this issue of say treating ash pond water. So even if there is a breach, or even if the supernatant from these ash pond flows to any river body, we can employ some cost-effective treatment to it. So if Dr. Sridhar, Dr. Priyabrata, or Dr. Sahu would like to add what I spoke, they're welcome.
Yes, sir. I think Pawan sir, you're right, and I think the supernatant can be treated further by coagulation, flocculation, and then it can be sedimented, and then the supernatant can go for back filtration or micron cartridge filtration to take care of that content, and then the solids can probably go for some reuse or to the landfill.
Yes, sir. I think that is already Dr. Sridhar, and you already covered that issue. So I think nothing more have to add here. Yeah.
Okay, thanks. Okay, so I request Rohini to write to us, and then as part of CSR consortium, we'll be able to provide solution to you, and we can discuss further. We can submit a proposal to you. We can even carry out detailed studies together and find out what can be the possible optimum solution for your problem. Thanks a lot. So now I request Mr. Iqbal Maniar to speak about replication of CSR developed wastewater treatment technology in the field. Your inputs will be highly valuable because we want more industries to connect with us, and that's the purpose of this particular event. And whatever technologies we are developing, that needs to be taken to the field with the help from industry. So over to you, and would definitely like to get your feedback and experience in this presentation. So over to you. Iqbal, Mr. Satish.
Good afternoon to all of you, sir. I can hear all of you. Over to you, Mr. Iqbal.
Yeah. Please go ahead. Do you have any presentation to share? I would like to speak only.
But Mr. Iqbal, Mr. Maniar would be presenting, sir.
Yeah, so Mr. Iqbal Maniar had to step out, so I am his son. I will be presenting on his behalf. My name is Farooq Maniar.
Yeah, please go ahead, Mr. Farooq. Yeah.
Thank you. Can you see my screen?
Yes. We are able to see your screen.
All right. So we are going to present the technology transfer that was done to Maniar a few months ago, and primarily we'll talk about the problem first, and then we'll jump into the solution that we have developed in joint conjunction with CSIR. So as you can see, right, on average, a human generates about 150 liters of sewage per day, which is astonishing because, from a consumption perspective, we only consume about 3 or 4 liters of drinking water. But the amount of sewage that we generate is about 150 liters per day. This could be your vessels, washing clothes, other activities. And on average, class 1 cities generate about 13.5 thousand MLD sewage on a daily basis. So what's the problem? So if you see, like when the cities were developed, the government put in certain infrastructure, keeping in mind certain population. And what happened was that this infrastructure was not developed to sustain the influx of extra people moving to cities. And what this has caused is, completely filled manhole chambers, choked pipelines. There are overflowing drainage water systems. Everywhere you see, we are seeing these problems. Now, there are solutions for all of these problems that we have developed over the period of years. And we'll go over them and why is that important? We'll talk about them. So let's talk about the first one, where the manhole chambers, traditionally the human had to go into it and clean up this sewage manually, and that was not humanly dignified. So if you see, this is the problem in the traditional functionality where the man is going inside. But on the right side, what we have developed was a desilting machine back in 2005, which solved this particular problem of not having the man to be sent under the manhole chambers, saving significant amount of lives over the period of years. Now we did get a significant, award from our Prime Minister Narendra Modi back. He was Chief Minister of Gujarat for the innovations that we did in the prior years and are leading up to Decent Man for human dignity. But we didn't want to stop there, right? So that was problem one, which was solving the manhole chambers. Now there are clogged pipelines again in the infrastructure, which is the second part of the drainage system. Now when these are clogged, we have to use the high jetting machines to unclog these using water. When we use water, we are using clean water systems. So we are essentially adding to the problem of sewage water that we already talked about, right? And then if you see, the third thing is the overflow drain. And for this, we developed the gully man, which can essentially help with the problem to avoid these overflow drains. But why innovate, right? I mean, we have the solution. What we saw was that, these are three individual products, but not a solution. We needed three different vehicles, more workforce, more diesel consumption, and this is not scalable as cities scale, as more humans move to the cities. So what we developed was a solution called Trombiman that allowed all the three equipments to be on a single machine or the single chassis, and this allowed to solve the problem of jetting, suction, and desilting in one. So you can use one human to do all of the three work, and saves a lot of time, energy, and human resource. But then why stop there, right? We always need to push the boundaries. What's the need to push the boundaries? We see that, we always, in India, we have scarcity of water. We have limited water on vehicles, like, with all the equipments getting on a smaller vehicle, there is only so much water capacity that we can carry on the vehicle. And then if you see, like, if you are trying to get foreign machinery, they are super expensive. And so it's important to somehow solve this problem, and that's where we jointly, with CSIR, develop this vehicle, which is the final result. What this allows is, basically, it has all the three things that we talked about, which is the high pressure jetting machine, the desilting machine, and the recycling facility, which solves the three drain problems that we talked about, which is the manhole chambers, the
চা
underneath
দিয়েছি, চায়ে চিনি দিয়ে দিলি,
Sorry.
চিনি দিয়ে দিই।
Please go ahead.
Please go ahead. Please go ahead. Dr. Sahu, I request you to unmute yourself, please. Mute yourself. Yeah. Maniar, please go ahead.
It solved the problem of the overdrain, the holes, and all of the three. Now the benefit here is that with the recycling facility added to this innovation, we don't need to necessarily carry all the good and the clean water to clean the underground drains, right? The high pressure jetting machine that we have can use the underneath drain water itself, self clean it using the recycling machine, and then use it for the jetting purposes. This solves the problem of not having to install a huge tank, also saves a lot of trips, and saves clean water usage for all the cleaning purposes, ultimately solving the problem of not adding to the gray water problem in the industry. The other benefit that we came up with as a result of this joint partnership is that this vehicle or this innovation is 6x economical to the traditional imported machinery that we have. And so it's important that as you see your needs for your city's infrastructure, help us, please reach out to us so we can help you design and plan for all the work that needs to happen to solve this liquid waste management problem. We have the solution for you, and we can work with you to solve these problems together. With that, I'll conclude. If you see on the left, these were the early stage products, which, as you can see, were individual products to solve individual problems. And then the next stage of development was the combination of that, which is the Trombiman. It solved the problem of having from three vehicles to a single vehicle. And the latest model is the one with the recycling machine that not only has all the three combination aspect of the three machines, but the recycling system that allows us to use the wastewater to clean the things. We have also added all the latest technologies such as camera, which can look into the drain systems to see which area is clogged and clean it up accordingly, just from outside through the screen watching. So we continue to innovate and we continue to improve the product as we speak. We will be happy to work with you if you have any specific needs, and you can feel free to reach out to us. Our details are here. We are a leading pioneer over from 75 years since 1946. We have been doing solid waste handling equipment, liquid waste handling equipment, and the truck mounted road sweepers, truck mounted cranes, stuff like that. My contact details are here. Mr. Iqbal Mania's number is here. Feel free to reach out to him, and if there are any questions, we'll be happy to answer them over here.
Yeah, thanks a lot, Mr. Maniar. Means it's very, very good to know about this particular innovation. So I was always talking about taking technology to the field, but this is another added component of, say, even adding to the innovation. So this is in fact a win-win situation for both CSR and industry partner. I think we need more such partnerships in future, and you have shown the path that how should we move forward, and then we can collaborate so that 1+1 will not only be 2, it will be 11. So thanks a lot for your inputs, and we'll definitely come back to you with questions here. Yeah,
Thank
as we go proceed. So we'll move to the last presentation of this particular session. So I would request Mr. D.N. Banerjee. And as we are running late, unfortunately we can extend this session by 15 more minutes because we started late. So I request Ritvik to kindly extend the timing to 12:15. And one panelist is not among us, so we can make out some time out, from his absence. So over to you, Mr. Bennett. Mr. Banerjee will also be talking about replication of these technologies in the field. So over to you, Mr. Banerjee.
Mr. Banerjee. Dr. Shahu. Dr. Shahu. Dr. Ganesh Shahu.
Dr. Shahu, is Mr. D.N. Banerjee here? Mr. Sahu?
Hello.
Yeah, Mr. Banerjee.
Mr.
Dr. Sahu, is Mr. Banerjee here? Because he is supposed to speak now.
Yes.
So, Mr. Banerjee, is he sitting with you or?
No, he's not sitting with me.
Okay, so where is he? Can you please contact him so that he can speak? Has he joined the meeting? Has he joined the event? Okay, Dr. Sahu, I request you to contact,
Yeah, I am calling to
Mr.
him.
Banerjee. And before he joins, now we can now start our panel discussion. So panel discussion will be facilitated by Dr. Sridhar. And Dr. Sridhar, over to you. And I would like to announce that Engineer Songadia, because he is the Engineer-in-Chief of Public Health Engineering Department, Government of Madhya Pradesh. He's caught up with one meeting. His additional Chief Secretary is with him. So he will be able to join slightly later. If he's not able to join, his colleague will join and briefly talk about say difficulties they face in technology implementation. But we'll go ahead with our panel discussion, and I'll now hand it over to Dr. Sridhar to commence panelists.
Yeah, thank you very much, Pawan sir. Thank you very much, and it's a pleasure to say.
Dr. Shahu, please mute yourself. Dr. Shahu.
Yeah, please mute.
Please carry on.
So good morning once again, ladies and gentlemen, and it's a pleasure to introduce the panelists for the first academic session now. We have the good fortune of having with us Dr. Asit Baran Mandal, former director, CSIR CLRI, and also outstanding scientist, and he's former INA distinguished professor as well. Welcome, sir. And we have got Dr. V.K. Shahi. He is a senior principal scientist from CSM CRI Bhavnagar, and he is well known for his expertise in electrodialysis, and is also heading the RO division now at CSM CRI. And we also have Dr. A. Gangagni Rao, who has been in the limelight recently for the waste to wealth program, especially the food waste and the vegetable waste. And one of the plants at the Bhavanpalli market has been a highlight in the CSIR recent past. So welcome to all of you, and at some stage we will be joined by
Dr.
Songaria ji.
Sridhar, sorry to intervene you. I think Mr. Alok Agrawal from PhD Madhya Pradesh has joined us. So,
Yeah.
Alok ji, आप हैं वहाँ पर? सुनाई दे रही मेरी आवाज?
Yes, sir. I am here. Good morning to all of you, sir.
Alok ji, for joining us. So, Mr. Alok Agrawal is representing Mr. Songaria.
Yeah, welcome Alok sir, and he is here on behalf of Sri K.K. Songaria ji, who is Engineer in Chief, PhD Madhya Pradesh, and probably we'll start with Dr. Alok himself. Sir, you have been implementing various water supply schemes, and among which water treatment remains a major component of these schemes. So, what are the challenges that you face in the field while implementing these water treatment technologies? That is one part. And then how can CSIR institutes connect more with rural water supply agencies in improving the implementation of CSIR's lab-based technology and taking it to the land, sir?
Okay.
आलोक जी, जस्ट मैं आपको ब्रीफ करना चाहूंगा, ये जो इवेंट है हमारा आजादी का अमृत महोत्सव का एक पार्ट है, और ये हमारा जो इवेंट है वाटर और वेस्ट वाटर ट्रीटमेंट टेक्नोलॉजी से संबंधित है। अभी हमने इससे पहले जो CSIR के 37 इंस्टीट्यूट है उसमें से करीब 15 इंस्टीट्यूट्स वाटर और वेस्ट वाटर ट्रीटमेंट पे काम करते हैं, उनकी टेक्नोलॉजीज के बारे में हमने बताया। और आप चूंकि CSIR नीरी और अन्य CSIR लैब से जुड़े हुए हैं, तो आपसे जो डॉक्टर श्रीधर ने सवाल पूछा उसका हम लोग आपसे कुछ फीडबैक चाहेंगे। और ये
सर,
हाँ,
actually, as you are aware, sir, we are implementing Jal Jeevan Mission in two ways. One is the multi-village scheme, and second is the single village scheme. Multi-village scheme is being executed by the Jal Nigam. There is that is the corporation under the Public Health Engineering Department, and Public Health Engineering department is executing the single village scheme. So in multi-village scheme, there is no such treatment problem because they are using the conventional treatment process. But in single village schemes, we have to look for the after installation and its sustainability. So we have decided to use the technology which should be able to work throughout the design period of the scheme, and there should be minimum interference of the public. Means that should require minimum interference, technical interference by the public, because all these schemes have to be maintained by the village water sanitation committee or the gram panchayat. So they cannot deal with the. Just a minute, sir, please. Excuse me. So we have actually we have experience of online chlorinator which we have used in the in some of the single village scheme which were executed during the 2013 and 2015. So those instruments were not properly worked because of the technical intervention which is required by the operation and maintenance agency. So as you told you that these schemes are being maintained by the Gram Panchayat or the VWSC. So we have a discussion with the NEERI and other stakeholders. So and we found that we should have technology which should require minimum maintenance and with minimum replacement of component which requires for the treatment of the or the disinfection of the water. because most of the single village schemes are based on the tube well or the dug well, means groundwater source. So we only require disinfection. And keeping that in our mind, we have implemented, we have incorporated some specifications which limit the supplier the quality, means we have limited the quality issues. We have described some specifications. One is that all the equipment which is to be used in the scheme for disinfection purpose, that should be evaluated. First, the technology should be approved by the CSIR, especially NEERI, because we are very close with the NEERI and we have very oftenly have discussion with the Pawan sir. So we are on the same platform. So we kept some specification like its technology should be approved by the NEERI. The product of the company should be evaluated by the NEERI with for all seasons, 3 seasons, means for this equipment should work properly for all the season. All weather equipment should be there for disinfection. So till date we are using 2-3 options. One is the silver ionization based technology. Second is ozonator. Third, some places we are also using chlorinator. But what we think, these equipments after installation at the site should also be evaluated by the CSI or the agency which has approved the product, because functionality at site is the different as compared to the lab. And the whosoever CSIR lab is approving the product of any company, they should also incorporate some clause in their agreement that they should evaluate these equipments at site also after some fair interval. So I think this should also be done. And if some agency's product is not functioning properly at site also, if you find, so there should be some कोई ऐसी लिमिटेशन होनी चाहिए कि वो उसको फिर आगे उस चीज को रोके आगे और वो सप्लाई ना कर पाए जब तक उसमें सुधार ना हो, या उस पर कोई ऐसा उस पर कोई एक्शन ना लेगा उसकी सुधार के लिए. दूसरा बात यह है कि कई लोगों का जैसे आपने एवेल्युएशन किया तो उसमें रिपोर्ट्स में बिल्कुल क्लियर होना चाहिए कि अगर है पास और सही है तो है, अदरवाइज लिमिटेशन विद कंडीशन अप्रूवल नहीं होना चाहिए. जिस दिन आप कंडीशनल अप्रूवल के साथ हमको देते हैं वो हमारे सर पर खड़ा हो जाता है कि ये लगाइए, हम नीरी की अप्रूवल लाए. हम उसको समझाते भी हैं कि भाई ये कंडीशनल है, इसमें आपको बोल नहीं सर, फिर आपको पता है सिस्टम में क्या चीजें चलती हैं, हम कितना परेशान होते हैं, कितना प्रेशर पर झेलना पड़ता है. और अगर अपन उसी चीज को बिल्कुल फेयर करते हैं, भले आपको वो कुछ भी फीस सबमिट करते हैं या कुछ भी करते हैं, अगर वो सही कोई चीज पर खरा नहीं उतर रहा तो उसको रोकें, उसको फिर उसको जब उसको प्रॉपरली ठीक हो जाए. क्योंकि हम तो आपके पास ही आ सकते हैं, आप उसमें पायनियर है, हम एग्जीक्यूशन में अगर काम कर सकते तो ये टेक्नोलॉजी उसको समझना, उसके प्रोस एंड कॉन्स हैं, उसकी वेदर से क्या रिलेशन है, एनवायरनमेंट से क्या रिलेशन है, वो सारी चीजों पे भी अपने को फोकस करना चाहिए. सर हमको अभी हम जैसे 2 टेक्नोलॉजी को हमको अभी तक कोई दिक्कत नहीं आ रही है, लेकिन फिर भी मैं आपसे वही कहूंगा कि इसका एवेल्युएशन एट साइट बहुत जरूरी है. भले इसके लिए कोई मॉडल अगर आपको लगता है जीओआई से कोई गाइडलाइन जारी होना चाहिए या कुछ हमारे लिए कुछ हमसे चाहिए जो कि हमको भी कुछ सरकार में पूछना पड़ता है या हमको बताना होता, तो आपके यहाँ से कुछ आ जाए, आपकी मिनिस्ट्री से आ जाए कि भाई इसको इस तरह से आपको इवेल्युएट भी कराते चलिए बीच बीच में, तो हमसे अगर कुछ उसकी फीस डिपॉजिट कराना है तो हमारे को भी कोई कारण या आधार होना चाहिए जिसके आधार पर हम करा सकें. क्योंकि हमारे यहाँ जब भी बात करते तो वो कहते हैं भाई जो एजेंसी ने अप्रूवल लिया आप उसी एजेंसी जिस कंपनी मतलब जिस CSIR से लगा उनको पत्र लिख के आप करा लीजिए, लेकिन आपके पास भी लिमिटेशन हो सकता हो कि आप कैसे करेंगे. तो मेरे ये कुछ सुझाव थे सर. और दूसरा ये कि 2 टेक्नोलॉजी के अलावा ऐसी कोई टेक्नोलॉजी और आगे अपन उसमें आगे काम करें सर जिसमें मिनिमम रिप्लेसमेंट ऑफ कंपोनेंट हो या किसी उसके लिए रॉ उसकी जरूरत हो मटेरियल की, वो डालना पड़ता हो या कुछ करना पड़ता हो और लंबे समय तक यूज कर सके ऐसे सिंगल विलेज स्कीम पे. क्योंकि सर हमारा जैसे अगर हम बात करें तो हम करीब 65% ऑफ द हाउसहोल्ड will be covered by the single village scheme.
Anup ji, thanks a lot. हम लोग आपके पास फिर से आएंगे. मैं I'll hand it over to now Sridhar. We'll come back to you. These are very important inputs from field perspective, because you're implementing that in field, and then we know now what sort of difficulties you face तो हम लोग कोशिश करेंगे कि किस तरह से सुधारा जाए. Over to you, Dr. Sridhar, and we can go around now. Yes.
Yeah. Meanwhile, Dr. D.N. Banerjee has joined, and we can take up his presentation at a later stage after this panel discussion. And sir, we have with us Dr. Mondal, who has been the former director of CSR CLRI. Sir, are you there?
Dr. Mondal. Sir. Dr. Mondal.
Yeah, he was there a while
He's
ago.
there, I think. Yeah, he's
Okay.
muted himself. He's
Yeah. Sir, you are muted, sir. Okay, sir. Meanwhile, we will go ahead with Dr. Shahi. So, Dr. Shahi, sir, can you update us on the recent developments in RO membranes and at CSM CRI, and also the electrodialysis membranes that you have been developing? So, over to you, sir.
Okay. Thank you, Dr. Sridhar. CSM CRI Bhavnagar is a pioneer institute for membrane science and technology, and especially for providing safe drinking water to the country. Institute is working from 0 ppm to seawater level up to seawater desalination, and we have developed several indigenous membranes like microfiltration, ultrafiltration, nanofiltration, hollow fiber, brackish water reverse osmosis, and seawater reverse osmosis for the water purification. In addition, recently we found that electrodialysis is also very useful technique for the water desalination and separation. We have also developed the indigenous ionization membrane, and recently the technology for the mass production of these ionization membrane has been transferred to Mazda India Limited, Ahmedabad. And reverse osmosis, hollow fiber, and brick membrane what developed that has been transferred to Rinjai Limited, Unifax Limited, and also
So, Banerjee, please mute yourself.
And also we are trying to here we are addressing Indian condition is very diversified.
কিছু প্রবলেম হচ্ছে
Mr. Banerjee, if you can mute yourself so that we can hear properly.
Actually,
Actually,
we are working
Mute
with
yourself,
your
yeah.
esteemed organization last 5 years. We are
Indian
using ceramic membrane.
আমি কিছু বলবো
Hello.
Dr. Mandal, I request you to kindly mute yourself, please.
I'm a senior engineer of Geolite.
আমি 5-6 মিনিট বলবো
Hello. So
আমি
we
এখন
are
মিউট করে
Shai,
রেখেছি
please go ahead. I request
unmute করবো
other audience to
Mandal
please
also.
mute themselves. Yeah, I request. Dr. Shai, please go ahead.
okay.
আচ্ছা
We are working now. You see in house-made water for water purification, RO everywhere RO. Where it is required RO or not.
No, we are using RO, but not using ceramic membrane. We are using ceramic membrane particular for.
Mr. Banerjee, we are asking, we are requesting Dr. Shai to speak. Please, we will come back
Sir,
to you.
can you all mute yourself so that Dr. Shahi will speak, sir?
Okay, sir.
Okay, so we have developed, suppose if it is groundwater and there is no TDS, ultrafiltration or hollow fiber is very useful technique for the water purification and to provide the safe drinking water. In these two technology, water recovery will be more than 95% because and that is the this technique will work if there is the salinity level of the water is 500, 700 like that. If the salinity level is higher than the this limit, then we'll do the nanofiltration. This also indigenous membrane is there, and if it is higher than the 1500 or 200, then we will use RO. Recently we developed the RO where
ভাবি শুনছিস
we can recover the water up to 80%. in electrodialysis, now Dr. Sridhar told alkaline water, now I am adding mineral balance water. We have developed the electrodialysis. In natural water, all the mineral ions are present, but RO removes everything. And the TDS is majorly maintained by the sodium chloride or their concentrated stream. We have developed the selective electrodialysis process where undesired means sodium chloride will be removed. All the bivalent like calcium, magnesium, sulfate, carbonate, bicarbonate will remain in the water. So this is the thing without any additional of external chemicals or only by removal of undesired we produce the mineral balance water. That is a very useful technique, and this technique will be also used since it is electro dialysis based technique to produce the mineral balance alkaline water. That is very good water where you have the natural ions in the water system, and you can tune the alkalinity of the water as per your body requirement or as per your desire. Recently, we developed the small vehicle mounted water purification system, which is self-operated by the engine to provide the drinking water during the natural calamities. It may be cyclone, earthquake, and we demonstrated this during the Gujarat cyclone last year and heavy flood in Ratnagiri area of Maharashtra. And so that technology is also becoming popular. And I think 1 week before we got order from the Kerala government to provide 3 such type of vehicle for the disaster management. So that vehicle will be very good if there is no electricity supply or if there is problem in electricity or so that technology vehicle can be used to provide the water at the door of the customer. If there is no water distribution system, houses is located in very remote area or such type of. So basically I can conclude the CSM-CRI having all type of indigenous membrane and these membrane has been commercialized. So I will request to all interferers, please use our indigenous membrane. Don't depend upon China because the Chinese membrane performance is not very inferior than our membrane membrane quality, and the price and all things it depends upon the manufacturer, and we have several supplied the technology to several manufacturers for any kind of membrane technology, because in one group the institute is working in all kind of membrane technology from wastewater, grey water, drinking water, sea water, every water we are handling. So please contact with us, and we are here to help the society and industry. Thank you.
Thank you, Dr. Shahi, for your insight into the CSM-CRI technologies and indigenous membranes. We will now go to Dr. A.B. Mandal, former director and former outstanding scientist and INA distinguished professor. Sir, are you there?
Hello, sir. Hello. Actually, Dr. Mondal just informed me he will be, he's willing to tell a few minutes after Dr. Shahi, and that's why I conveyed you.
Yeah.
I think maybe there are some connection problem.
Yeah, maybe connection problem. Meanwhile, we will go ahead with Dr. Gangagni Rao. Sir, can you highlight on the CSR ICT's technologies on the biological treatment of wastewater, and recently about the biomethanation combined with the membrane bioreactor and side stream nanofiltration as well? You can throw some light on that, sir. Over to you, sir, Dr. A.G. Rao.
Can you listen to me?
Yes, sir. Yes, sir. Yes.
Yeah. Good morning to all of you and Dr. Sridhar, Dr. Pawan, and all three of you who are the coordinators of this event. Thank you so much for giving this opportunity.
Thank you, sir.
Interesting, actually, panelists are listening each and every point. A very lot of nice points are coming up, actually. In fact, if I look at this whole from morning, CSIR has done a lot of good work in the area of water management, wastewater treatment, actually. We should all be proud, actually. That is much I can definitely tell you. And our experience is first is that we have done one work here, integrated solid and liquid waste management and treatment, actually. In that, what we have done is, whatever the kitchen waste is coming, we have treated anaerobic digester. And at the same time, we kept one more plant, membrane bioreactor, aerobic membrane reactor, wherein sewage and kitchen waste water is treated. And the treated water from this membrane bioreactor is directly being used for this, land application, for this cultivation, again back for using utensils, and also we are using, actually. And whatever the sludge generated in the membrane bioreactor, we have used in the same in the anaerobic digester and generated biogas. So this is the integrated solid liquid waste management using anaerobic digestion membrane bioreactor. This project we have demonstrated under DST program, and now this has become very successful, and we have uploaded videos in the net also, and we are going for DST also. Now we are aggressively propagating this gated community in all the places. This technology, because all the gated communities, they are generating a minimum of one ton of waste, food waste, and vegetable waste, and they are also generating at least minimum of around, I think, I can say at least 10 to 15 meter cube of that wastewater from the colony. That is like, sewage water, domestic wastewater, and all these things. Why can't they implement such technologies and recycle back entire water and solid waste in terms of biogas as well as solid manure as usable water? So this is the crux of the problem, and we are aggressively promoting this. And we are also talking to pollution control board and regulatory authorities, asking them to propagate this technology. And now in Hyderabad, actually, now from October, the rule is coming. We spoke to JHMs and PCB also. They are putting very stringent conditions, saying that all gated communities, they cannot send their waste outside. They have to be treated inside only. So with this technology will become prominent. This is the one technology which we have done and which is becoming popular. And I think across CSR, we have to propagate these technologies and tell to everybody, each and officials, everybody saying that there are simple technologies, cost-effective technologies, and we can use local instead of increasing the load of sewage and solid waste on these municipal authorities and urban local bodies. Secondly, one more interesting point what we have noted is that, Hyderabad and some places, a lot of bulk drug industries are there. Now there is a rule that all the bulk drug industries, they have to implement zero liquid discharge. And fortunately, a lot of industries are doing this, but they are using very costly technologies, like they are using multiple effect evaporation, stream tripping, and agitated thin film dryer. And after all doing this, actually, they are disposing the solid waste to toxic facilities, and they are putting again membrane or RO system at the end to recycle the backwater. And if you see the unit operations, we have visited so many SMS Pharmaceuticals and Lee Pharma, so many companies in the recent past as a part of the project, DST project. We understood that almost, they are spending around 4 to 5,000 rupees per kiloliter. That is the amount of money they are spending for the treating the wastewater with this, multiple effect operation, ATDFD. All these are the energy intensive processes, actually. So then we did a small study, we did a small experimental pilot plant also we operated, where we can intervene with this biological treatment so that the cost of the whole treatment can be reduced. We have innovated a process called biological sequential process, that is called BioSAC, and we installed one pilot plant here. We demonstrated to all the bulk drug industry, and what we told them is that instead of stream paper, they can put biological treatment, and they can get based on the characteristics, it can vary from 30 to 60% CO reductions, and along with CO reduction, they can also get ammonical nitrogen. Ammonical nitrogen removal is very, very important nowadays. These four standards are very stringent. And this BioSAC process also can make an intervention in condensate treatment. Multiple effect and ATFD condensate, The COD is in the range of 30 to 40,000. Ammonium nitrogen is in the range of 400 to 506 milligram per liter. So instead of using regular simply aerobic system where we are getting only partial CO reduction, we can use this biosec process, sequential biological process for the removal of simultaneous removal of CO and ammonium nitrogen. That is what we can make intervention. That is what I told you. And there is another stream in industry in bulk drug industry called low TDS and COD, low TDS and COD. COD is in the range of 20,000 milligram per liter, and TDS is approximately, I can say, 5 to 10,000 milligram per liter. So that streams we can directly use this process, and we have how we can intervene. So my request is that we have to help the industries. See, it is that industries are also very much interested in implementing newer technologies, reducing the cost of operation, reducing the capital cost. It is that scientists we have to intervene and give them. And of course, we have to educate them many times. We have to educate them many times in different forums. Then only it will get into their mind. In fact, actually, the SNS pharmaceutical immediately they'll implement the technology after seeing the pilot plant here, and we have given a design of around 40 KLD plant already designed we have given to them, and most probably they'll be implementing this technology. They can intervene in their existing entire spectrum of their wastewater management. Our biosec can find a very good place, and this biological sequencing process can find a very good place actually, and they can like reduce cost of operation. I say that it is not the completely treatment; it is a part of the treatment it can take. That is what actually for ZLD process. And one more interesting is that all of these bulk drug industries are everybody having ultrafiltration or reverse osmosis or any membrane. Everybody is installing membrane system. So why don't we combine these biological membrane systems and develop a very robust systems? We have to combine this biological and membrane bioreactors, aerobic or anaerobic. This is the need of the our in bulk drug industry. I request all of the people like Satyabrat and all the people like Pavan and Sridhar, all these who are the experts in this waste water and wastewater. No, we had actually CMCRI and all the people actually know this. They should look at these membrane reactors very seriously, anaerobic and aerobic membrane reactor, because we can integrate those two principles very nicely, and industry can find a solution. And membranes also, indigenation of membranes also very, very important actually. So wastewater treatment now it is becoming very, very complex. See, the industry is already implementing biological treatments for the simple wastewater like food processing, spent wash, so many things actually. But as a scientist, I think we have to do solutions for complex wastewaters. Complex wastewater. That is where the challenge is actually. Simply giving solutions for simpler solutions, which already is in the market is available. Our role is very limited over there. Maybe some working like improving the efficiency and all these things we can give. But whereas developing a novel solution for the complex wastewaters, it is very, very important. I think it is a duty of our scientists to do it. I think actually, after visiting so many bulk drug industries, interacting with them, doing this project, I learned so many things. I thought that still a lot of work has to be done in this area. So that is, I think, now we should for a consortium. I'll request Pavan, Sridhar, and everybody, and all people actually to actually join and start a consortium and find a very interesting solution for this bulk drug industries and chemical industry wastewaters. So then I think we can give really a good solution for them. And industry people also are really very, very cooperative. They are also looking for solutions. When I enter the industry, actually, I found that they are very enthusiastic actually. So with these few words, I would like to conclude. I can answer and thank you all of you for your kind permission to talk.
Thank you very much, Dr. A.G. Rao, for proposing this integration of biological process with membrane as the tertiary treatment to achieve ZLD, and especially with COD removal in the focus. Pavan sir, shall we move on to Dr. Professor A.B. Mandal, if he's still there?
Yes. Sure. Is Dr. Mandal here? I can't see him. I think it's
Yeah, yeah.
finding it difficult. So Priyabrata again can contact him and let us
Okay,
know
sir.
if he'll be able to.
I'm trying.
I think he could join in the next panel discussion. Shall we move ahead with the next panel of
Yeah, I
industry?
think, yeah, before we move, I have a question from audience. To those who are working on membrane, like Dr. Shahi, are you there? Dr. Shahi, Dr. Sridhar, even Dr. Rao also, and Dr. Sahu. So the question is, this is related to membrane technology. Most of the components are from market and only membrane is part of IP. Then how are you commenting that you are cost competitive? So yeah, I don't know whether I could properly put the question. It's not very clear, but what he or she means is that, okay, IP can be only membrane. Otherwise, we bring in all other components from the market. So how can we claim that we are cost competitive? So Dr. Shahi, either yourself or Dr. Sridhar can respond to this question of audience.
Sir, in my opinion, apart from IP for membranes, we could also have design as one of the components for the generating the IPR. So system design is also another component that can be like an indigenous design. So a patent can be filed for an indigenous design as well. And as far as like minor components are concerned, it is always like the choice of the CSIR to go for a low cost solution to combine with their membranes, because generally CSIR doesn't really produce, it's an R&D based system, and it will make the membrane and then assemble the plant as per the novel design, and the components will be as low cost as possible. And as long as these components are indigenous, I think it will only spread the economy further and contribute to the revenue.
Yeah, thanks, sir. Yeah, thanks. Yeah. Now we can move forward. Yeah, Dr. Mandal is not there. So
yeah,
what should we do? There's a presentation by Mr. Mukherjee. I don't know. Sridhar, over to you.
Yeah. Sir, I think we can go ahead with the presentation by Dr. D.N. Mukherjee, and then by the time Dr. Mandal will join the next panel discussion, we also welcome Sri Satyajay Mayer, the one of the pioneers of membrane technology in India, and so he has joined and will be participating in the panel discussion. Banerjee sir, can you share your screen and then move on with your presentation? Zeolite. Sir, you are muted, sir. You are muted.
Yes, yes, sir. We are using your membrane last 5 years. We are only using 19 channel ceramic membrane, particularly for removal of arsenic and fluoride.
Slightly louder. I'm unable to hear you properly. If you can slightly be louder.
Just a minute.
Sir, if you have a PowerPoint presentation, you can share quickly, sir.
No, I do. Actually, I have not prepared actually.
Okay,
so,
next time,
next time we can submit PowerPoint presentation also.
Sure, sure. Please give your.
Particularly, two things is very important. One is cost of the membrane little bit higher nowadays. It is around 25% increased. So if it is possible to maintain the price same as before, it will be helpful for us to manufacture a low cost water treatment plant, particularly fluoride removal, arsenic removal, and also turbidity removal. Secondly, if it is possible, we can use for RO system also, because your permit is more, reject is very less. That's why we are very interested to use your membrane, particularly in this field. If possible, I will implement our technology and our setup also. I will change accordingly. This is very important for us because no one in Eastern Zone are using this technology, particularly in this reverse osmosis. And also ultrafiltration also. So I will contact accordingly to CCRI also, develop our technology. On the basis of your know-how, we are also licensed both.
Yes, Dr. Ganesh Sahu is there, who is representing CGCRI today. So you can be in touch with him, sir.
We have a very good relation with the CCRI also. So accordingly, we are jointly doing one project also recently. It will be installed in Sundarban. Particularly in Sundarban, the water is saline water. If salt irrigation is more, irrigation wastage is very less, that is permit is more, we can use ceramic membrane technology in, but cost of the membrane nowadays it was increased. So this is the one of the problem. Cost of the all the material increased, including electrical device also. So that is my point. If it is possible to hold this price in this around, it was 4-5 years before 2000, around 2000. Now it is 2,800. Around one piece of 19 channel membrane.
19 channel.
This is my point.
Thank you, sir. Thank you for your remarks on the ceramic membrane, and also look forward to further collaboration between your company and CGCRA and also other CSR labs. So I am also now very happy to introduce the industrial panel, and we have with us Sri Narendra Ahuja ji, HES Water Engineers India Limited, India Private Limited from Maharashtra. Welcome, sir.
Thank you so much.
Thank you, sir. We also have Mr. Saurav Ganguly, who has joined us from the beginning, and welcome again, sir, Mr. Ganguly. And we also have, he is from Zenith Aquatech in Shivpur at Howrah. And we also have Mr. Sri Satyajay Mayer, Director, Permonics Membranes Private Limited, who has helped scale up many CSR technologies and taken them from lab to land, both in water and wastewater treatment. And we also have Mr. Satish Machiraju, and he has been having quite a good partnership with CSR Labs. And so we will begin with.
Good afternoon.
Thank you, sir. We'll begin with Mr. Ahuja, and I think Pawan sir has a question for him.
Yeah, Mr. Ahuja, welcome.
Thank you, sir.
Very experienced person in this domain. You've been working in water treatment for several years. And most importantly, you also interacted, collaborated with the various CSR laboratories, and you have been implementing CSR's technologies in the field.
Yes.
And so I would like you to share your experience of collaboration or taking technology from CSR laboratory to the field. How should we evolve? How can we make ourselves say better, or how can we make technology transfer simpler? So what's your experience and what's your message to CSIR?
Thank you, Dr. Pawan. Thank you, everybody. Good morning, and wishing you all a very, very happy Azadi Ka Amrit Mahotsav, everybody here. We have been associated with the CSIR for many, many years. In fact, our association started with NERI in 2012, 2013 with the EDF, electrode defloration plant. Then we have association with CMERI for the high flow iron arsenic removal plant. And recently we have signed an agreement with CSI Ampli for their handheld electrochlorinator. Actually, electrochlorinator is very close to our heart. We have this product for the last 16 years. We have been manufacturing them. We have installed close to 3,000 plants in India. And right now our order book is more than 10,000 plants in that. Our interaction with CSIR labs has been wonderful. I mean, CSIR has an ocean of scientists, a wonderful team of people. And they cooperate very well. Coordination with them has been wonderful. The technologies are working very, very well. All the three technologies are good, excellent technologies.
Thanks a lot.
And now coming to, like EDF. EDF is, I think, one of the best technologies in defluoridation. No doubt on that. It has some small drawbacks, like it requires operator intervention all the time. So our idea was, can we make it a continuous model? It's a batch model right now. I think Dr. Pawan would recall that we had done some work together and then somehow it did not go ahead. So our feeling is your interaction, you should encourage industry to come up with ideas, cooperate with them, coordinate with them. I'm sure industry will be eager to even fund the projects, with this. But your expertise is required there. Your expertise can be a wonderful experience for us and for the society as well. It can help society as well. At the same time, government should give much more, autonomy to CSRI labs, I feel, because there are many things which get stuck in the bureaucratic hurdles and approvals and this and that. That part, as government should take care of. Otherwise, I think it's a wonderful team, and our experience with all the three labs has been really, really good. Really, really good. A while ago, Dr. Agarwal was speaking from PHE. In fact, I sent a question also to him. They have, they're doing disinfection with silver ionization plant. It has been approved by NIRI. Yes, absolutely no doubt about it. But after having installed that plant, I do not think any evaluation has been done on that. Any department, any government department, we are safe water, safe drinking water is a very sensitive subject. It's a very, very important function. So what departments can do is they can coordinate with the CSI NIRI or other CSI labs and have long-term agreements with them, to monitor the performance of the products. That's very, very important. Otherwise, what happens is once the product is installed and the contractor, the supplier takes his payment, everything is forgotten. There are maybe 60 to 70% plants, I'm not talking about silver dustion, in any other areas also are dysfunctional because there's no one to take care. There are no experienced operators in the market, in the field, and there's no monitoring of the systems. So monitoring of water quality is, I think, is one of the most important factors which needs to be taken care by CSIR lab, particularly NIRI, which has been in this field for, Yes.
I am sorry to interrupt, sir. Sir. Actually, I think
Dr. Thanks, Ahuja. I think Dr. Mandal is with us. Mr. Ahuja will come back to you. I think we enjoy this wonderful partnership a lot. Over to you, Dr. Sridhar. Dr. Mandal is with us, and we'll carry forward our conversation with our panelists later.
Dr. Mandal is very happy to have you here and look forward to your views on how we could improve the collaboration between CSIR labs and the industry, sir. And also your take on the tannery effluent and how well and you managed it very successfully, the tannery effluent, sir, at CLRI. So the successful management of this tannery effluent also you could throw some light upon, sir. So we are happy to have you here.
Yeah, sir, namaskar. Sir, we can hear you, sir.
Please go ahead, sir.
Sir, we can hear you. You please go ahead. Actually, I think there are some problems with the network. His phone. So.
Sir is back. Yeah, sir is back. Yes, sir. Mandal, sir, we are looking forward to hear you, sir.
Okay.
Yeah.
Sorry, because there are some network problem. Again, reconnected somehow.
Yes.
Good morning, all of you.
Good afternoon.
All of you have done well. It's my pleasure that when Dr. Banerjee, Priyabodha Banerjee gave the link and all these things, he was kind enough and telephoned me. And Swachha Mujumdar from CGCRI, he has suggested. Then I told, okay, as long as I am here, so I can attend. as you know that this is a very this is. Are you audible? Am I audible?
Yes,
Hello.
sir.
Yes, sir.
Am I
Yes.
audible?
Yes.
Hello.
Yes, sir. You're audible, sir.
Not audible.
Audible, sir.
Hello?
Audible, sir.
Sir, please go ahead.
Oh,
Sir, audible. Sir, you are audible. I think Dr. Sridhar, I think there will be some network issue or he
So,
can't.
sir, we will go ahead with, yeah, he's come back.
Yeah. Sir, please tell us a few words. Sir, you are audible.
Yes, you are audible, sir.
now it's okay. Am I audible?
Yes, yes.
Yes, sir.
Okay. Again, I'm repeating this kind of thing that you know the important subject when I was director for Central Leather Research Institute from 2006 to 2016. We have had a lot of network program, CSR network program, and I had the opportunity to act as chairman, task force committee chairman. So I had got important call from Ministry of Science and Technology. That is Dr. Harshvardhan, Minister of Science and Technology. Then I had got so I met Minister also. Then we told that our earlier government we gave the proposal, but it was not implemented. But now they wanted immediately to implement. Then they asked me that can you do within 2 months? I told 2 months is short for me. We will give the proposal in 3 months. So I think I remember in 2015 by April, May, we have given the proposal, and they immediately gave the grant.
Yeah, I think network issue again. Should we wait for a couple of seconds or we go for the next?
Dr. Sridhar, we can go ahead because he was not audible also. He's back. He's back if we can speak.
Some problem is there, I think.
Yes, sir.
Sir, continue. Please continue.
Please continue, sir.
Hello?
Yes, sir. We are able to hear you.
Am I audible now?
Yes, sir. Please go ahead, sir.
Okay, we then come shortly again. So
got the problem.
okay, Dr. Sridhar, so go ahead. Next speaker.
Now it's okay.
Yes, sir.
Problem, network problem. Huh?
Sir, we will contact you later on then. Okay, sir.
Some network problem. Huh?
Yeah.
Yes, sir. Yes, sir. There are network problems, so we will contact you later on. Thank you, sir, for your great presence. We are really delighted of getting you with us.
So,
sir, we are very much thankful to you for your great presence. We are delighted, sir. Thank you, sir. So we are now, sir, moving to next speaker, sir, with your permission. Thank you very much, sir. Okay, Dr. Sridhar.
Yeah, thank you, Mandal, sir. Now we come over to Mr. Saurav Ganguly. Sir, you have had a long-term association.
I don't know whether I'll be able to speak. afterwards?
I think
Because
Dr.
serious
Banerjee, you can contact sir on
something.
the phone.
Huh?
And,
Okay, I am doing that.
yes.
Is a serious.
Sir, yeah. Sir, Saurabh Ganguly, sir, you can discuss your partnership with how the partnership with industries can be improved for technology translations, and share your previous experiences as well with CSR Institute, sir.
Thank you, Siddhar sir. Good morning, everyone. Before starting, I want to convey my sincere thanks to CSIR for inviting me in this particular conference. And it is very good to see the initiative that CSIR has taken in the field of water and wastewater. Sir, I'm audible, sir?
Yes, sir. Yes, sir. You're audible, sir.
So it is genuinely good to see the initiative that CSIR has taken in the field of water and wastewater treatment. Our journey with CSIR CMERI was excellent as we are working in the field of drinking water, and the particular territory that we are covering, the greatest threat as on date, that particular area, we have just received the data from IMIS, that is Integrated Management Information System, published on 6 August 2017, that the area of West Bengal, like of Malda, Murshidabad, Nadia, 24 Pargana, Bankura, and Purulia, is affected with the greatest inorganic threats, that is fluoride and arsenic. And thanks to Dr. Priyobroto Banerjee, the entire team of CSIR, CMERI, Anjali Madam, and everyone, their particular cooperation and assistance helped us a lot to penetrate the fair technology, as we are the authorized licensee of fair technology of CMERI, CSIR, CMERI. And not only into West Bengal, sir, due to the particular grace of God, we are also working in Bangladesh, Nepal, and Bhutan. In the coastal areas also, we have found the same particular problem, contaminated with arsenic and iron. There, we got the chance to implement the fair technology, and it is performing beautifully, sir.
Thank you.
We want to show our sincere thanks to Dr. Priyobroto Banerjee, cooperating us every time. Any problem that we have faced, he has simply cooperated us a lot to resolve the problem. And with the particular guideline of CMERI, we have also developed a particular small fair technology filter, which will help to, because government cannot extend their hand and reach everywhere, sir. So with the help of CMERI, we have developed a particular filtration plant, potable water filter for domestic use, capacity of 30 liters per day. And the cartridge was being developed with the guideline of Dr. Priyobroto Banerjee. Surprisingly, it can reduce iron from 15 ppm up to less than 0.2, which is more or less a magic for us. So thanks to Dr. Banerjee, and as well as we are also working to the industries, we are getting few particular problem or facing few particular problem of a contamination of higher phenolic compounds, heavy metals, and oil and grease, as we are into coal water treatment plant. In this particular aspect, if CSIR can enlighten us with the particular guideline and technology to resolve the problem, we'll be grateful to CSIR. And I will also request either, sir, like the coastal areas we are working in Bangladesh and also into Purva Mednipur, the waters are highly contaminated with salinity. Like of the salinity part, we are already working with your SW membranes, means seawater membranes we are already working or using. But for the smaller plants that we are finding problems like of 250 LPH and 500 LPH, where the feed pressure required is more than 18 kg.
Yes,
so we are not finding proper solution of the pump. And in few areas, there are problem with the electricity also. So if we get any sort of particular guideline how to resolve the problem, means we'll be grateful, sir.
Sure.
And again, thank you very much for inviting us. And over to you, Siddhar, sir.
Thank you. Thank you very much, Ganguly sir. And it was really wonderful to see your contribution along with CMERI Durgapur in mitigating the sufferings as far as arsenic, iron, and fluoride, and some of them combined contaminants together in Bengal, Northeast, and even in neighboring countries. So it's really wonderful to know about these contributions. Thank you very much, sir, for joining us, and we will find solutions for the two points that you have given us, and we will come back to you on that subsequently. So now we have with us Mr. Satyaja Mayer. Sir, can you switch on your video? Hello, Mayer sir, are you? I will just try to contact him. Meanwhile,
Yeah.
Pawan sir, if there are any other questions for the experts, you can go ahead with that.
Yeah, sure. See, is Mr. Agrawal here? Mr. Alok Agrawal, are you there?
Yes, sir.
Yeah, अग्रवाल जी हमारे चैट बॉक्स में एक question and I think Mr. Ahuja also talked about it. I'll expressly put it to you. He has mentioned that you were talking about this disinfection processes, and it's mentioned that to the best of our knowledge, PhD is only specifying silver ionization, and that too only one manufacturer has monopolized. Electrochlorination is one technology which is being used extensively by several state government for JJM, and users also extremely happy. We have CSIR approval for the same. Why is the department hesitant in introducing other technologies? We agree that products should be evaluated by CSIR on regular basis while in use. And he also spoke about having some, say, agreement with CSIR NERI or other CSIR laboratories so that the product works properly. And if the product doesn't work properly, then the severe stringent punishment can be given. Would you be able to highlight on this issue?
Yes, definitely. Actually, we have never specified any technology. We have only said in our document that it should be CSIR approved technology and product should be evaluated by any CSIR lab. So this was the written in the document. Some of the division we have also received this complaint that some of the divisions has mentioned particular company's name. So we have written that they should not write any company's name. Only the specification and the criteria for selecting the technology and the equipment they can mention. You rightly, and this is not correct that we are only using the silver ionization technology. We are also open with the silver ionization, with the ozonization, with chlorinator. But the condition is that the product should be evaluated by the CSIR lab and the technology should be approved by the CSIR lab. This is the criteria. If someone is putting the name of any company, that we do not accept. If someone has done it, then we will definitely write to them that they should not do like that.
Yeah, thanks a lot for that clarification. So, Ahuja ji, one thing we are going to resolve now, I will just quote an example in brief. I received a call from senior officer from Jal Jeevan Mission, and then he was asking about various technologies. So what he told that we should be technology neutral. See, if you define characteristics of treated water, you should comply with BIS 105002012. Then I think the technology is good because every technology has its own space, its own limitation. So what Alok Agrawalji has mentioned that there will not be technology specific if the product is say certified or evaluated, not certified, if it is evaluated by any CSR lab or CSR NERI, they will accept it. So with this resolution, I think we can go ahead. I think we will not have time to discuss it further. I request you to be in touch with Mr. Alok Agrawal. And then I'm sure that as he committed here, they will be technology neutral and they'll be happy to say propagate whatever technology it is. And from CSR side, I definitely commit on behalf of my colleagues also will extend as much of help as possible, not only to PHT Madhya Pradesh, even to Jal Jeevan Mission and other states, that our community gets safe water.
सर मैं एक और चीज ऐड करना चाहता हूँ
हाँ बोलिएगा बोलिएगा
सर मैं ये कहना चाहता हूँ, क्या होता है सर, टेक्नोलॉजी जितने भी मैन्युफैक्चरर हैं वो एक्चुअली जब आते हैं हमारे पास, जब हम ये बात करते हैं कि इट शुड बी एवेल्युएटेड, योर प्रोडक्ट शुड बी एवेल्युएटेड विथ सीजनल वेरिएशन by any CSIR lab. So actually, I think some fees or kind of structure has been developed by the CSIR कि इतना पैसा जमा करने पर एक्चुअली दैट अमाउंट इज आल्सो ए बिग अमाउंट फॉर देम। तो उनको ये लगता है सर कि ये सब करने में बड़ा झंझट है, तो उनको लगता है कि जिन लोगों ने कराया बस उनका चल रहा है। ऐसा नहीं है सर, एक्चुअली जो लोग कराते हुए आ रहे हैं हम सबको, हम उनका एवेल्युएशन हमारे यहाँ, आपको भी पता है सर, आप टेक्निकल कमेटी की बैठक में भी आए थे, स्टेट लेवल टेक्निकल कमेटी हमारी जिसमें सारे चीफ इंजीनियर्स हैं, ENC साहब उसके हेड हैं, तो हम लोग वहां पर उस प्रोडक्ट का जो आप एवेल्युएट करके भी भेजते हैं उसको भी हम रखते हैं। देन वो कमेटी उस पर पूरी रिपोर्ट को पढ़ती है, हम लोग शेयर करते हैं आपकी रिपोर्ट, फिर वो अपना कमेंट करते हैं। उसके बाद वो जैसे अभी एक प्रोडक्ट के लिए उन्होंने आपके यहाँ से एक कंडीशन, मतलब एक किसी वेदर के लिए वो आया था, रेनी सीजन या किसी में हुआ, 3 सीजन में नहीं हुआ, तो उन्होंने, हमारी कमेटी ने कहा भाई जब सबके लिए बराबर नियम रहे, अगर किसी का हम 3-4 सीजन के लिए करवा रहे हैं तो सबका एक जैसा रहना चाहिए। ऐसा नहीं कर सकते कि किसी को 4 सीजन के लिए हम बाहर करें और किसी को 1 सीजन पे अलाउ करें। तो ये सर कुछ चीजें हैं जो बाद में भी हम लोगों को देखना पड़ती है कि किसी के लिए अलग अलग मापदंड ना हो। तो मेरा ये निवेदन है, अगर ऐसा किसी के पास कोई भी टेक्नोलॉजी जो कि ऑपरेशन मेंटेनेंस फ्रेंडली है, वो बिल्कुल आए, कोई समस्या नहीं है, वो अपनी रिपोर्ट्स के साथ आए, आपके यहाँ से एवेल्युएटेड हो, आपका पूरा सिस्टम उन्होंने एवेल्युएट करा रखा हो। अगर हम कॉन्फिडेंट हैं सर, हमारे पास तो कोई और स्टैंडर्ड है नहीं माप करने का कि सही है प्रोडक्ट या नहीं है, क्योंकि ये हम स्पेशलाइज, हमारा सिविल कोर वर्क सिविल वर्क है सर। तो अगर वो आते हैं तो डेफिनेटली हम अपनी कमेटी में रखेंगे सर और उनको अलाउ करेंगे। और हम अगर कहीं सर, हो सकता है, मैं बिल्कुल इसको डिनाई नहीं करता, 50 डिवीजन, 52 डिवीजन, 56 डिवीजन में से हो सकता है 6 डिवीजन ने कहीं लिख दिया हो सकता है। तो अपन उस चीज को उनको बोलेंगे कि भाई ये चीज आप टेक्नोलॉजी नहीं लिख सकते, इट शुड बी रिटन एज द डिसइंफेक्शन यूनिट सुटेबल फॉर फला फला, एंड जो स्पेक्स रहेंगे डॉक्यूमेंट में वो स्पष्ट है सर। हमारे यहाँ से राइटिंग में गया हुआ कि इट शुड बी नीरी CSIR एवेल्युएटेड एंड CSI अप्रूव्ड टेक्नोलॉजी। दैट्स इट सर।
ठीक है अग्रवाल जी, मेरे ख्याल से हमने इस पे हमने काफी डिस्कशन कर लिया है। मेरे ख्याल से एक अच्छी बात ये हुई है कि इस माध्यम से, इस इवेंट के माध्यम से हम कुछ रेजोल्यूशन ला सके। और एक और आप जानते होंगे कि अभी पहले डॉक्टर मशेलकर की कमेटी हुआ करती थी, अब वो प्रिंसिपल साइंटिफिक एडवाइजर की कमेटी, उसके द्वारा भी बहुत सारी टेक्नोलॉजीज इवेल्युएट होती हैं और रिकमेंड होती हैं। तो हम एक वो टूल भी इस्तेमाल कर सकते हैं जब भी हम स्टेट लेवल पे ये टेक्नोलॉजी प्रोपोगेट करना।
उसमें भी मैं आपको क्लियर करूं सर, उसमें टेक्नोलॉजी अप्रूव्ड का तो बात आपने बिल्कुल सही कहा, उसमें उन्होंने कमेंट रिकमेंड किया सर। लेकिन क्या होता है सर, मैं आप कोई इस पे उसको आक्षेप नहीं करना चाहता सर, लेकिन बहुत सारे लोग ऐसे आते हैं सर जिनके पास कल से वो कुछ करके और इधर आ जाते हैं कि ये मेरा फला टेक्नोलॉजी फला जगह से अप्रूव। सर हमको ये भी देखना है कि वो उसकी कैपेसिटी है नहीं है, उसने उस अपना प्रोडक्ट उस तरह से बनाया नहीं, ये सब हम एश्योर नहीं कर पाते।
बहुत सही बोल रहे हैं अग्रवाल साहब। मेरे ख्याल से हम लोग एक अभी पिछले महीने ही इस कमेटी की मीटिंग हुई थी और जल जीवन मिशन से भी सीनियर अफसर थे वहां पर और ये सब सवाल उठे थे वहां पर। तो मेरा निवेदन है आपसे कि आप उनको भी थोड़ा सा कम्युनिकेट कर दें, मैं भी अपने माध्यम से कम्युनिकेट करूंगा। पर हम लोग ये इंश्योर करना चाहेंगे, चूंकि अब हमारा समय भी खत्म हो रहा है, कुछ हमारे स्पीकर्स हैं, कि इस मामले में हम स्टेट के साथ मिलकर और जो इंडस्ट्री के साथ मिलकर जरूर काम करेंगे। और ये जो रेजोल्यूशन की बात है, जो कॉन्फ्लिक्ट रेजोल्यूशन की बात है, इसमें जरूर मदद करेंगे, क्योंकि हम लोग MP PhD को भी अच्छे से जानते हैं। मैं बोल रहा हूँ कि रूरल वाटर सप्लाई एजेंसी को हमारी सारी लैबें अच्छे से जानती हैं, उनके साथ मिलकर काम करती है, इंडस्ट्री के साथ मिलकर काम करते हैं। हम ये चाहेंगे कि ये जो इस तरह की जो थोड़ी बहुत समस्याएं आती हैं उसको हम कैसे सुलझाएं। आई एम श्योर कि ये वर्कआउट होगा। तो समय के अभाव की वजह से हम इस विषय को यहीं पर रोकते हैं और आप दोनों का इस पे धन्यवाद देते हैं। हम फिर से इस पे अलग से चर्चा करेंगे। ओवर टू यू डॉक्टर श्रीधर, बिकॉज इट वाज रियली गुड डिस्कशन एंड आई एम रियली हैप्पी दैट we are able to resolve this issue, and we'll come back to you, Ahuja ji and Agrawal sir.
Thank you, sir. Thank you, Dr. Agrawal.
Thank you very much, sir. I think Mr. Satyajay Mayer has joined us, and welcome, sir, and for being one of the pioneers of membrane technology in India. And way back in the 70s, the FRP vessels were being made at Baroda, and the membranes were also being made, flat sheet membranes mostly. He has been concentrating. So, Mayor sir, we would like to have you sharing your experience with IICT and CSIR labs, and also what the future holds for membrane technology in India, sir.
Well, good afternoon, and thank you very much for inviting me on this forum. And I won't take too much time because I think we've already run out of a lot of time. So, well, my experience with CSIR goes back to 1994, I think. Sridhar, correct me if I'm wrong. I think before that, my father used to work with Dr. I think Taki Khan. Wasn't he there?
CSM CRI Bhavnagar, yes, former director.
No, and before there was another director of IICT, when it was not IICT, when it was
RRL.
RRL. Taki Khan, yeah.
So probably Permionics' association goes back to when it was RRL way back in 1984 or 85, I think, when Dr. Surirajan visited India. I think he also visited, I think, RRL at that time and CSM CRI. So I think the relationship that we have, we basically are a membrane manufacturing company and offering customized solutions in the membrane separation space. So we're always looking out for new membranes, new technologies, and new processes. I think Sridhar's lab has come out with a lot of innovation and a lot of innovation at low cost, which is of course the need of the hour now when we're looking at trying to bring back things to make in India. And our, I think, thrust will always remain with searching for new membranes and new processes and new, I would say, materials. And I think it's with the kind of resources that CSIR has, I'm sure there is much more that you can do than what is being done today, because I think what is important is benchmarking. Our technologies need to be benchmarked with what is currently available today. Not just to say we have developed a technology and we have it, but it has to be current. It has to be competing with what is internationally available. Just because in Indian we should not expect the technology to be slightly inferior. Which unfortunately, I mean, I'm sorry to say it in this forum, we do find that, and there's a lot of work that needs to be done to scale that up. But I think IICT and Sridhar's lab is working on a lot of process solutions using existing commercial technologies of membranes as well, which I think is also a much bigger challenge than just making a membrane. Because membrane is membranes fairly are very standard across the world in terms of the RO membranes or the NF membranes. The chemistries are very well known, the chemistries are standard, but it's how you use them, how you design systems, and how you design pre-treatment is also a very, very major role it plays in determining how successful your project is. And I think that's where we have learned the very hard way. And since we make our own membranes, of course, we find membranes, we can afford to sacrifice membranes in plants by, doing a lot of trial and error as well. Because I don't think when you're working on the commercial scale, you do not have that kind of time and, time and resource to experiment before you come up with a solution. Once you have a plant and site, you need to understand, you need to work quickly. So I think there's a kind of a very fine dividing line between process development in the industrial scale and process development in the kind of come closer together to improve, I think, the quality of output and the improve the timelines so that industry benefits, on an immediate basis, not on tomorrow's basis. I think that's what I have to say. And I think we have a long journey ahead with CSIR and IICT. And I'm sure we will be working on more technologies to try and put them into, we are working on the electromembranes now, I think, Sridhar. So yes, we are there for you to scale up technologies as far as membranes are concerned. So about the future of membranes, I think if everyone, I think Dr. Shahi gave an interesting lecture on electrodialysis, on how I think that's a very underrated technology today. I think this technology needs much more thrust and much more work in making it more efficient. I think at some point, there will be a point where it can come and, cross over the RO technology and make the combination of the two technologies very efficient. I think this is some work that I think CSIR labs can do in terms of the process, not just in making the membrane, in terms of the process of how electrodialysis can become a more efficient way of, competing with RO or complementing RO. Because RO chemistries haven't changed. RO membranes haven't changed. People are trying incremental. Today, you're almost having 100% rejection membrane, 99.85, 99.9%. I mean, we're reaching a point of absolute perfection, which, I mean, is a bit unbelievable. But of course, when you do test membranes, you do find them to be giving that kind of rejection. So I think the future of membranes still lies with RO and the polymeric membrane chemistry, which is the TFC polyamide. And I think that's there to stay for another 5 to 10 years. So, and unless there's some major breakthrough, I mean, people have tried graphene, people have tried, nanosilica, people have tried, I think carbon nanotubes, but they've all remained, I think, in the nanofiltration or ultrafiltration range. I think there needs to be a little more understanding of commercial applications in the R&D, in the scientific community, so that, industry is able to make use of that knowledge much faster and much more efficiently than what it is happening today. I think, Sridhar, you're doing the right thing by exposing yourself to industry and by in commissioning actual plants in what, like one of the plants that we did in Mumbai.
Yes.
I think actual need of the hour in the science community.
Yeah, and the other
technologies are saturated, to be honest, as far as chemistries are concerned.
Yeah.
Work on process development and process enhancement. And in chemical engineering, you call process intensification. But so I think that's all from my side. And thank you again for giving me this opportunity.
Thank you, sir. Thank you very much for your useful inputs. And also, there was another plant recent which is now running successfully since 4 years. That is at Haldia Met Coke. That is around 5 meter cube per hour, and that is for chloride separation, nanofiltration. So it improves the water recovery to 85%. So that has also been a very good collaboration. Apart from the several plants, including one on gas separation as well, which we made an attempt at Hazira. Which went to technical success. So, and thank you for your focus on electrodialysis as a complementing technology to RO. And I'm sure that CSR can rise to the occasion with the chemistry part and take your help. All over, like all the CSR labs can take your help in scaling up their membranes and the processes. So with this, I would like to thank all the panelists for their wonderful inputs. And over to you, Pawan sir, for the closing remarks.
Yeah, thanks a lot. At the outset, I would like to thank everyone, all the speakers or analysts. They really did wonderful job. Our speakers from CSR, they talked about all our technologies pan CSR. So it looked like a team CSR presentation, and we covered almost all the labs which work on water and wastewater treatment technology.
Sir, we could have a couple of points from Sri Satish Matsjaraju also. He's online.
Okay, please. Yeah, we can request him.
Yes, Matsjaraju sir, please go ahead.
Comments.
Yeah. So thank you very much for your time, sir. First things first, I think from Tata Motors, I would like to convey our sincere appreciation for Dr. Pawan and Dr. Priyabrata for bringing all the stakeholders to this platform. Also, I wish to put on record our appreciation for CSIR in commercializing several technologies. I think a lot of them are in the interest of the society. We are seeing the basic thing that's happening across states, and we've been supplying a lot of vehicles, is how do we remove manual scavenging? One success story that comes to my mind, and which was led by Mr. Avinash Yadav, was on how the technology know-how was transferred to us on vehicle-mounted drain clearance system. So as Tata Motors, I would only want to promise and sort of commit myself to this journey, and we want to partner with all of you. There's a lot of modularity that is happening in the automotive industry. With modularity, these are like Lego blocks. I can make any vehicle for any particular applications. So somebody wanted a smaller vehicle to go into the villages. it can be made. Somebody want a larger vehicle to be going into the areas and geographies which are bigger, that can meet. So basically today auto technology is like Lego blocks, like those kids play. So all the tailored made needs for any treatment, be it natural, industrial, municipal, condensate, we are there, sir. My promise to all of you is this: our engineers and field service personnel, I'd offer them with cutting edge technologies. What I also want to mention to all of you, sir, I think we must start leveraging digital now. We are seeing a lot of digital play that's coming across. If we can develop apps together, and then probably at some point of time we will see this industry, I'm talking of these particular applications, moving into build, operate, transfer. So somebody who's in need, I think our senior scientists will be asked to manage their entire waste on their own. Yes. So an app which is developed like what we call as the urban clap will help the consumers and the service providers to come together. That's all from my side, sir. Thank you once again for giving me the time. Thanks a lot.
Thank you very much.
Thank you, sir. Over to you, Pawan, sir. Thank you very much, Machiroju, sir.
Yeah, thanks a lot. I think it is very, very interesting session, and all of you spoke very, very well. I would like to particularly thank our industry partners and Mr. Alok Agrawal from Public Health Engineering Department. And they have highlighted what actually they expect from CSIR. On one side, we have government department which actually have their own issues to resolve. Secondly, we have partner from industries. And we can really play a catalytic role in resolving these issues, and how can the technology of CSR be taken to the field for the benefit of both industry and society. I'm sure, and to just add to the point of Mr. Satish, that we have another session from 2 p.m. onwards, on which we are talking about IoT-enabled water treatment, water supply system. And we are developing our own app, and we are also developing our own dashboards through which entire water supply system can be monitored. So that can definitely be integrated with water treatment technology we talked about. And thanks once again, and I'm sure that CSIR will continue to play a catalytic role. We definitely need both government departments as well as industry to really carry forward these innovations which we do primarily for helping both society and industry. And I'm sure that with a slight tweak in our policies, we'll be able to say benchmark ourselves, as Mr. Mayor talked about say on timeline, on cost effectiveness, on superiority. We will definitely say reach to that level, because our scientists are doing excellent job, and I'm sure with the help of both industry and government will ensure that our technologies will be better than what is available in world over. So thanks once again, and with this we'll close the session, and thanks a lot for your time. Thank you very much.
Thank you, sir. Thank you.
Thank you.
Thank you. Thank you very much. Thank you, Ananda.
Thank you.